So this lesson, we're going to be graphing polynomials without using a calculator at all. And so we're going to use everything we've learned the last few days about polynomials, plus I'm going to add a few extra things. So first, something we did last week, we were looking at a polynomial that is in intercept form. We can find the degree of it basically by adding up all the multiplicities. So this one is going to be degree 4. All right, and then the leading coefficient, as long as none of these x's have a coefficient, the leading coefficient is going to be the number that is outside of the parentheses. So in this case, the leading coefficient is -1. And then based on what we learned yesterday, we can figure out the end behavior. So the leading coefficient always tells you what happens on the right side. This, as x approaches infinity, is the right side. And if I have a negative leading coefficient, then on the right side, this graph is going to be going towards negative infinity. And then we're going to look at the degree to determine what's happening on the left side. So because the degree is even, then the left side is going to do the exact same thing as the right side. All right, and then this y-intercept is new for today. It's not new totally because you guys have definitely found y-intercepts before. We just haven't done it this year. So the y-intercept is always the value of the function when x is 0. So what we'll do is just put 0 in for x, all the x's. All right, and then we're just going to simplify this down. So 0 plus 3 is 3, and 3 squared is 9. And then 0 minus 1 is -1, and 0 minus 5 is -5. All right, so now I'm multiplying a negative times a negative times a negative. So anytime you're multiplying and there's an odd number of negatives, it gives you a negative. And then 9 times 1 times 5 is going to be 45. So your y-intercept is at 0, -45. All right, and multiplicity is something we studied last week. So in factored form, I can just find the multiplicities by doing the opposites, or find the zeros, the zeros by just doing the opposites, and then the multiplicities is going to be the power on each of those factors. And so that we'll have a 0 of -3, and because that factor was being squared, it's going to have a multiplicity of 2. All right, we're going to have a 0 of 1. That one did not have a power, so the multiplicity is 1. And then our last 0 is 5. And it also didn't have a power, so its multiplicity is 1. All right, so we have a lot of information about the graph. We're going to find one more thing, and that next thing, the last thing we're going to find is another point on, or another ordered pair on the graph that's not a 0 or an x-intercept and not a y-intercept. So I'm going to pick -1. So I'm going to find f of -1 because it wasn't, obviously the y-intercept would be 0 when x is 0, but it also wasn't a x-intercept. All right, so that's the negative, and then that's going to give you 2 squared, which is 4, times -2 times -6. All right, so a negative times a negative times a negative is still going to be a negative, and that's going to be 8 times 6, which is -48. So that is a point on the graph. And this is all stuff you can do without a calculator. It can be a little tedious, but it's still extremely doable. So now let's graph these things. So I'm going to start off and graph the y-intercept. Now it tells you to choose an appropriate scale. If I need to get on the y-axis down to -45 and -48, I'm going to go by tens. And my y-intercept was -45, so I'll put a point there. All right, that additional point I found was -1, -48. It's going to be a little lower than -45, but not quite to -50. Right, then I'm going to graph my zeros and remember their multiplicity in a second when I go to draw the curve. But I do know I have a 0 or an x-intercept at -3, at 1, and at 5. All right. And then looking at my end behavior, both the arrow on the left and the arrow on the right should be pointing downward. And this -3 is just kind of like a little extra special 0 that it's not going to go through it. It's going to just bounce at it. So I'm going to start downward, pointing down here, and then I'm going to go to my 0. I'm going to bounce. I'm going to go to these points. Now I don't know if that's the very lowest or if it goes lower, so I'm just going to use what I know. I could be wrong. It's okay. I'm going to go straight through because the multiplicity is 1. Curve back around and go straight through. And that's a graph. Now, it should go lower or higher than this, or maybe not as high, but we are just using the information we have to get the best graph that we can. Because we don't need a calculator. Okay, now let's look at another example. This one is a little different. We start off with the graph, and we're still going to be able to find all the same things. And then in the end, we're going to be able to write the equation for this curve or for this polynomial. Now, finding the y-intercept is a little easier. We just look and see where the graph crosses the y-axis. That's at the point 0, 4. All right, and then we can find the zeros and their multiplicity by looking at the x-intercepts and looking at what happens at those x-intercepts. And when I look at -2, it just goes straight through. And when the graph just goes straight through at the 0, it's a multiplicity of 1. And then the same thing happens again when x is 1. All right, 4 is another x-intercept, but when I look at it, it's something weird happens. It does this little bend, and when you see that little bend, there's going to be a multiplicity of 3. All right. I also think the end behavior is slightly easier to do. Whenever you have the graph, you don't really have to remember anything but what the notation looks like. So the first limit is when as x approaches infinity, which is the right side of the graph. And on the right side of the graph, the arrow is pointing downward, which means that limit is going to be negative infinity. And then the limit as x approaches negative infinity of g of x, we have an arrow pointing up on the left, which means that limit is going to be equal to infinity. Okay, and when I do the degree, it's like we talked about before. You're just going to add the multiplicities. So this one is going to have a degree of 5. Now, these ones, the majority of the work is going to be in this section right here where we're finding the leading coefficient. So this graph is called g of x. So I'm going to start off and I'm going to write an equation for g of x, but we don't know the leading coefficient, so I'm going to call it x. I'm going to call it a. And then I'm going to write factors using my zeros and their multiplicity. Now, we have already done this when we did that speed dating activity or the quiz trade activity. But when we were doing it, we didn't worry about the leading coefficient yet. So this is a little different. We have to have that a there. And then we're going to find the value of a by plugging in the y-intercept. And our y-intercept on this one was the 0.04. All right, so I'm going to put 4 in for the y, or for the g of x, and I'm going to put 0 in for x. And then that's going to leave us an equation that the only thing we don't know is a, and we can solve for it. Now this one gets a little bit more difficult because we need to cube -4 without a calculator. So if that's not something that you know, you would need to actually multiply 4 times 4 and get 16, and multiply that by 4. And then a negative cubed is going to still be a negative. All right, and now I need to do 2 times -1 times -4. If you don't know what 64 times 2 is, just do it the old-fashioned way. And because I only have 2 negatives. Oh, I messed up somewhere. Sorry. Let's go back and fix this. That x-intercept was -1, which is going to make that be a +1, and that be a +1, and that be a +1. So I only have 1 negative. So -64 times 2 is going to be -128a. And then I need to divide by the -128. Now, if this was free response, it would be perfectly fine to leave it unreduced. You can leave it as -4 over 128, and I would 100% accept it. If it's multiple choice, definitely you would want to reduce it. I'm going to go ahead and reduce it. All you have to do is take 4 and divide it, or take 128 and divide it by 4, and you get 32. So this reduces to -1 over 32. Now this particular one was kind of tedious. The ones you guys have to do work out a little nicer, so don't get too stressed out about reducing those fractions. But now, once we have a, what I can do in this very last step where we give the equation is take that -132, and we're going to put it in for a, and then all this is going to stay like it is. And that's my equation for the function in intercept form.